Hey everyone, so previously we were talking about moles and we saw that moles is a unit of the amount of substance that always measures exactly 6.022 exponent 23 particles. Now it could be atoms, it could be ions, it could be molecules. And we even saw the fact that having same moles of two different substances does not necessarily mean the same mass, because moles concerns itself with the number of particles, the mass could be very much different. And then we saw that in order to find out moles, we have three different methods. We did not look into the methods, but we know there are going to be three methods. In today's video, we're going to be concerning ourselves with majorly solids. We're going to see how we can use the formula, which is mole is equals to mass of a substance divided by the atomic mass or the relative molecular mass. Recalling that AR means relative atomic mass of an atom, obviously of an atom, while MR means the relative molecular mass. It means the relative molecular mass. Obviously this is for compounds, molecular mass. So in today's video we're going to see how to find out the relative molecular mass, because AR is already in the periodic table. The AR values are already from the periodic table. But we'll see how to find out the relative molecular masses, and we'll see how to find out the number of moles. Over here I have some questions with me, and we're going to see how we use this formula, which is the number of mole is equals to mass divided by the MR. First, let's see how to find out the molecular mass of a substance in the first place. For example, I'm going to be using this pen. I know that for sodium hydroxide, I have to find out the MR, because the question says what are the molecular weights, which means another word for MR. So let's see. Guys, sodium hydroxide is a compound. It has one sodium, it has one oxygen, and it has one hydrogen. Sodium has a mass of 23, oxygen has a mass of 16, and hydrogen has a mass of 1. Obviously we know this from the periodic table, right? From the periodic table. And adding them we get 40. Now what's the unit for molecular mass? The unit is going to be grams per mole, which means how many grams are there in 1 mole sodium hydroxide. So this is the unit of MR. This is the unit of MR. Let's try this other question, which is phosphoric acid. Let's use some other color. It has 3 hydrogens, it has 1 phosphorus, and it has 4 oxygen atoms. 3 times 1, because each hydrogen is 1 gram by mass. Phosphorus has a mass of 31 units, and 4 oxygens have a mass of 4 times 16. We get 3 plus 31 plus 64. And when we add it, we obviously get it 98 gram per mole. So 1 mole of phosphoric acid has a mass of exactly 98 grams. Let's try this difficult one, which is question 6, because you know water is very easy. Let's try question 6. Over here let's use some other color. For example, I'm using this purple. We can see that nitrogen and 4 hydrogens are in a bracket, and there's a 4 outside it. So there's a 2 outside the bracket over here. So nitrogen and 4 hydrogens are there in the bracket, and there's a 2 outside it. And then we have a sulfur and 4 oxygen atoms. So nitrogen has a mass of 14, 4 hydrogens have a mass of 1 times 4, and then there's a 2 outside the bracket. Sulfur has a mass of 32, 4 oxygens have a mass of 4 times 16. 14 plus 4 times 2 plus 32, and then obviously 64. When we add it, we finally get it 132. So this is the molecular mass of ammonium sulfate. This part is obviously the ammonium ion. NH4 means ammonium, and SO4 means sulfate. So this was actually ammonium sulfate. So we know how to find out the molecular masses. We have only done 3 questions, but we are pretty sure how we can solve few more of such questions. Let's jump to question 2. Let's see what it says. It says, how many moles are there in 22 grams of argon? Now we know that we are concerned with number of mole is equals to question mark, and we have the mass is equals to 22. For argon, since it's an element, we don't have the molecular mass, rather we have the atomic mass is equals to 39.94. So let's use a calculator and let's see what the values are. When we find out the number of moles over here, mole is equals to 22 divided by 39.94, and we're going to try it to get to know that it's actually 39.94. Finally we get it 0.550 moles of argon. Let's see the other question. It says, how many grams are in 88.1 mole of magnesium? Now this question is a little tricky. It's asking for how many grams, it's asking for the mass, and it has already given us the moles, It says mass is equals to question mark, but mole is equals to 88.1. And since magnesium is an element, it has an atomic mass of 24. We know this from the periodic table. Let's try it. We know mole is equals to mass over atomic mass. 88.1 is equals to mass, which is unknown, divided by 24. We just give this 24. On the other side we get 88.1 times 24 is equals to the mass. We solve it and we see what the answer is. So we multiply 24 by 88.1 and we get to know 2114.4. So it's 2114.4 grams of magnesium. We have our answer ready with us. So let's put these answers in a box. I don't know why am I doing this, but it just makes it, more aesthetic, I guess. Let's try question 6 perhaps. It says how many grams, so again it's asking for the mass. It says how many grams, which means mass is equals to question mark, are in 0.02 moles of beryllium iodide. So it's like mole is equals to 0.02, and beryllium iodide is a compound, so Mr is equals to the mass of beryllium plus the mass of 2 times iodine, because there are 2 iodines over here. And we know that beryllium has a mass of 9 units. So beryllium has a mass of 9 units, and each iodine has a mass of 127 units. So I can write over here as well, 127 times 2. When we add it, we get to know that actually 127 times 2, and then we plus 9. So we get to know 127 times 2 plus 9 gives us 263. So this is the gram per mole molecular mass of beryllium iodide. Let's find out the rest of the part. We know mole is equals to mass over Mr. Mole is already 0.02. We don't know the mass, but we know the Mr is 263. The mass is going to be equal to 263 times 0.02. So we just multiply this value by 0.02, and we get to know that the the mass is going to be equal to 5.26 grams. 5.26 grams. So we know how to find out the number of moles, perhaps if the mass is given, or the mass if the mole is given. Let's try the last question very quickly. It says how many moles. So we know that moles are missing. We know that moles is equals to question mark. We know 68 grams of copper hydroxide. So mass is equals to 68 grams. And for copper hydroxide, we know it's going to be the Mr. Copper has a mass of 64, and there is a 2 indeed outside the bracket for OH. So it's going to be 16 for oxygen, 1 for hydrogen times 2. 64 plus 17 times 2. So essentially it becomes 34 plus 64. So we're going to just find out the molecular mass, and it turns out to be 98 units. So 98 units over here. We know the formula is mole is equals to mass over mR. We don't know the moles, but we know that the mass is 68, the mR is 98. When we divide 68 by 98, for example 68 divided by 98, it becomes 0.693. So the mole is equals to 0.693 mole copper hydroxide. So guys, in today's video we talked about how we can find out the molecular mass of a substance by using the atomic masses from the periodic table. We solved some questions by using the formula moles is equals to mass over the mR. In next video we're going to be jumping off to the idea of how to solve moles for gases. So stay tuned guys.